Hey everyone, welcome back to Mr. Leith Math Hub, where we guide you on your journey of learning mathematics. Alright, we break the math in as simplest way as possible. I will try to explain every ins and outs as it regards to each topic that we're doing. Alright, if you're new to the channel, I really appreciate you coming through, and I really hope that you will stay by hitting that subscribe button. And if you believe that the video is of help to you, please leave a like. Alright, thanks for everyone who has been watching the videos that I've uploaded already. Right, I really appreciate you guys, and I hope you continue to support me as I'll be able to support you guys eventually. We're on the topic of fractions, and it's a very simple topic, while it cannot be sometimes. All right, and I think that has to do with you properly understanding what fraction basically entails. Fraction is such a way that it can be used to represent many things. All right, it can be used to represent a share of something, the usage of something. And when I say usage, I think about let's say for example you have a stadium. You have a stadium which basically have a capacity of, let's say, 400 persons. All right, for argument's sake, 400 persons. All right, and function is held, and there's a total amount of, let's say 253 person scheme. All right, so remember the 400 is the capacity, while the attendance is 253. So if you want to represent the amount of persons who actually came as a fraction, everyone knows that we put the total, which is the 400, that's the capacity. All right, that would represent the entire whole car. That's what the stadium can hold. All right, always go in the denominator. If you remember that always go in the denominator. All right, that always go in the denominator, and how much is actually used comes in the numerator. All right, so that would be a case or I have right here. So all right, so this would represent how many persons who actually attended our function. All right, if we want to speak about how much actually did not attend, basically we know that we basically subtract the 253 from the 400. All right, and that would basically give us how much? 147. All right, and that's out of the 400. So this is how much seat that was not occupied. All right, so that represents how much seat that was not occupied. All right, so that's basically representing fractions. Just remember, the denominator represents the entire thing, the capacity, how much is actually there to share or to use. All right, while the numerator represents how much is actually used or taken or anything like that. Depends on the scenario that you're using. All right, I will have explained those in the previous video. So for this video, basically we want to focus on basically being able to add and subtract our fractions. All right, so there are basically two ways that we're going to basically show fractions can be represented. Well, there are basically three ways. Like that is basically having the same denominator, unlike that is basically having different denominators, and when we have mixed numbers, and basically working with mixed numbers and changing them to improper fraction before we do anything at all that we're doing. All right, so let's say for example we start off by using, let's say we're gonna add, so let's say we have 3. Let's say we have 3. Let me just change the color of this. So let's say we have 3 out of 7. All right, so 3 sevenths, and we're gonna add that to, let's say we have 2 sevenths. All right, so let's say this is basically representing a share of 7, and what we have done is that the first fraction represent that 3 shares out of the 7, while the second fraction represent 2 shares out of the 7. So they're basically trying to dictate how much was actually shared out of the 7. All right, so what basically happens is that with fraction and this addition and subtraction, whenever you're adding and subtract fractions, the key thing is basically having the same denominator. That's the key thing. That's the very most important thing. All right, though we cannot use very and most, which is a very important thing, the most important thing that you need to know. All right, so our aim is to always ensure that our denominators are the same. All right, in this case they are the same. All right, so what basically we do is that we're going to keep that same denominator because it's still out of 7. But how much out of 7? All we need to do is that we just need to add the numerator that we have right here. So that's going to be 5. All right, so that's a 3 plus a 2, so that's a 5. All right, so what this represents is that when we add 3 sevenths plus 2 sevenths, what we're going to end up with is that we're going to end up with a 5 over 7. All right, what we did is that we keep the denominator at the numerator. All right, same thing if we have, let's say we have 4 over 13, we're going to add that to 5 over 13. All right, so this denominators are still the same, right? So what we do is that keep the denominator because it's the same, and as such what we do now is basically just add what's in the numerator. 4 plus 5, everyone knows that's 9. All right, so that would represent our addition that we needed right here. So we can do one more. Let's say we have let me read your mind. So let's say you have 13 over let's say 25. 13 over 25 plus, let's say we have 4 over 25. All right, so what we'll do right here, so still the same thing. The denominators are the same, obviously, so we keep it. Once it's the same, we keep it. All right, and what we do now is basically just add what's in the numerator. That's the 13 plus the 40, the 4, not the 14 but 4. All right, 13 plus 4, everyone knows that's 17. All right, in cases we might have fractions that can be reduced. So let's say we have 4 over 11. No, let me not use 11. Let's say we have 4 over, let's say 15. All right, plus, let me say 6 over 15. All right, so we realize right here, so is that we have same denominators again, so we can keep it. All right, but what we'll do the numerator now is that we'll add the numerators. So we know that 4 plus 6 is going to give us a 10 as our numerator. Looking at this, remember we say that whenever we have a fraction and the numerator and the denominator can be divided by a number other than 1, we can basically reduce that fraction. So it must be reduced by the same number. So the same number must can go into the numerator while also being able to go into the denominator. So it must can go into both of them. All right, so looking at that, we can basically see that what can go into 10 and 15, the largest number we can think of, is basically 5. All right, that's the only number that 5 and 1, those are the only numbers that can basically go into 10 and 15. All right, so if we say that now, we say 5 into 10 goes 2 times, and 5 into 15 goes 3 times. So what that leaves us with now is a reduced fraction of 2 over 3. This 2 over 3 still represents that 10 over 15. What changes is that we just reduce the fraction. Remember, we always reduce the fraction once there's a number that can go both into the numerator and the denominator, and that number must be the same number. And that's the most number that can go into the numerator and denominator without leaving a remainder. All right, so if there were other numbers, so for example 2, 3, and all of that, we would have used it. All right, or we could have used it. All right, we already explained the concept of reducing fractions. Again, if you really want to learn that, you can watch our previous video that we have basically uploaded. All right, so that's basically adding fractions with like denominator. Let's look at subtracting them now. All right, so let's say we have a 10 over 13 minus, and we're gonna minus 4 over 13. All right, again, the denominators are the same. So addition and subtraction, they follow the same concept. And this is basically, once the denominators are the same, all you need to do, keep the denominator, subtract the numerator. 10 minus 4, 6. All right, this cannot be reduced, so that would have been our final answer. Likewise, if we have so we have 13 over like 17, we're gonna minus 7 over 17. All right, in this case, denominators are still the same, so that's 17. All right, and then we have 13 minus 7, and 13 minus 7 will leave us with what? 6. All right, so this would have been our final answer, 6 over 17. All right, concepts still remain the same. Once the denominators of both fractions are the same, all we need to do is just keep it and just subtract or add the numerator. And this is only for addition and subtraction. Common thing that persons are doing is that they're mixing up addition and subtraction rules with multiplying and dividing rules. All right, please try and understand the rules, all right, and know when to use them. That's a simple concept. Whenever you're adding and subtracting fractions, what you need to ensure is that the denominators are the same. That's what you need to ensure. If they are the same, your life is far, far easier. All right, all you need to do is keep the denominator and add or subtract the numerator. All right, can look at a few more examples. Let's say we have 17 over 24 minus, let's say a 9 this time, over 24. All right, denominators are still the same, so say 24. All right, so then we say 17 minus 9. 17 minus 9 would leave us with that 8. All right, and yes, looking at this, it can be reduced, right? Or we know that it can be reduced is that there are other numbers other than 1 that can go both into the numerator and the denominator. That means they have a common value or a common factor. All right, so if we can use 2. All right, we can use, what else can we use? We can use 4. We can use 8 itself. All right, we're gonna use the largest number because we believe that's easier to use. All right, so we'll say 8 into itself goes 1 time, while, all right, let me use one different color to show that 8 into itself goes 1 time, and 8 into 24 goes 3 times. So that's gonna leave us now with a reduced fraction of 1 over 3. All right, and again, this reduced fraction still represents our 8 over 24. All right, so this 1 over 3 is still representing this, just that it reduced. It's in a reduced form. All right, let's say we have give me a number. All right, I heard 9. So 9 over, let's say we have 9 over 19 minus 5 over 19. All right, denominators are still the same, so we keep it. All right, now what we'll do with the numerator is to subtract them, so we're left with 4. This cannot be reduced, so this would have been our final answer. And that's basically understanding addition and subtraction of fractions with light denominators. All right, so let's say we have a 2 over 3, or we're gonna add that to 1 over 2. All right, so this is what we have. All right, looking at this, we can see very clearly that the denominators, they are not the same. All right, you realize that this time they're not the same. All right, that's where this method come in place. So what we call or finding our LCM. And what does LCM mean? It means the lowest common multiple. So that's the lowest number that both of these denominators can go into. All right, that's the lowest number that both denominators can go into without leaving a remainder. All right, the thing about it though, if you use, for example, you do not use the lowest, all right, it's not gonna be totally wrong. As a matter of fact, it's not wrong any at all. All right, it's just that in the end you're gonna have to do some reducing. All right, or you would have to do more reducing that you would have actually done if you use the lowest. All right, so that's just the basic of it. Just ensure you find a number that both 3 and 2 can go into. If you use the lowest one, the lowest value, as I would call it LCM, the lowest number that both of them can go into, you'd basically, your life is much more easier. If you're supposed to do any reducing at all, it's going to be a simple reducing. Whilst if you have a bigger number, you know that takes more reducing. And probably hesitate or having a problem finding the common factor for both of them to reduce them. Alright, so when you're finding LCM, all we basically do is that, as we just said, the lowest number that both of them can go into. My little trick that I use to basically find LCM is that I try to see if the lowest number can go into the biggest one without leaving a remainder. And we're talking about the denominators. So I try to see if 2 can go into 3 without leaving a remainder. Alright, that is not the case. Alright, once 1 can go into the next one, all I've done is that I've just multiplied both of them. So I multiply 3 times 2, and if I multiply 3 times 2, I'm going to get 6. So that's going to give me my LCM. Alright, sometimes in a case where sometimes it using multiplying both of them doesn't give you the lowest. But again, if I told you that even if you don't get the lowest, you're not wrong. It's just that in the end you're gonna do more reducing. Alright. So that's just my little way. Instead of wasting time I try to find the lowest. Alright. Once 1 can go into the next one, all I've done is just multiply both of them together. Alright. And multiplying both of them together, it basically help you with the next step that we're gonna do. Our aim or purpose of basically finding our LCM, or aim of finding our LCM, is basically what we call equivalent fractions. So we're making both of them equivalent fractions. Alright, in such a way that we're trying to make them have a common denominator. This 6 down here, so is now a common denominator for both of these fractions. Alright, I'm gonna show you on this side what that basically means. Alright, so we just said that we have just now created 2 new fractions. Well, not new, but equivalent fractions for both of these terms. Alright, and that is now basically having a denominator, a common denominator of 6. Alright, so what we do basically is that we try to figure out how exactly did this 3 turn into a 6, or exactly this 2 turn into a 6. We know that we multiplied this. Let me change the color. Multiply this 3 by 2 to get a 6. And we have multiplied this 2 by 3 to get a 6. Alright. That's why I basically multiplied both of them. Because it basically helped me to dictate these. Alright. Help me with these. Alright. I've multiplied a 3 times 2. Get my 6 down here. So multiply 2 times a 3 to get my 6 down here. So, and it's basically always the opposite denominators for each of them. Once you multiply them to find the LCM, it's always the opposite denominators. Alright, whatever you multiply the denominator by, just multiply the numerator by it also. That's a simple rule of equivalent fractions. Whenever you multiply the numerator by a number, whenever you multiply the denominator by a number to find the LCM, multiply this numerator by that same number. Alright, so in that case now, would have a 2 times a 2, that's now going to give us a 4. Alright, and that 4 is going to be represented over here. So plus 1 times a 3, that's going to give us a 3. And that's going to be our new fractions over there. So, and if we're adding this, it's going to give us the denominator come back. Alright, because they would have a common denominator like the previous ones. Alright, and then 4 plus 3, that's going to give us a 7. Alright, and then the same thing over here. So the denominators are the same. 6 come back. 4 plus 3 That's going to give us 7. All right. And if you don't believe these are the same thing as these over here, so if you don't believe that, let me show you. If we have 4 over 6 and I'm supposed to reduce this, if I'm going to reduce this, all right, what can go into both 4 and 6? 2. All right. So if I divide 4 by 2, I'm going to get 2. If I divide 6 by 2, I'm going to get 3. So that fraction is now going to be a 2 over 3. And that's what we had originally up here. So same thing with 3 over 6. What basically, all right, let me use the block. 3 over 6. 3 over 6. If I'm supposed to reduce it, what can go into both of them? Clearly 3. 3 into itself one time. 3 into 6, 2 times. So that's now going to leave us with a half. All right, and this half is the same as this half that we had originally up here. So, and that's the basic understanding of fractions. All right, what you need to understand, I know that there's a lot of things going on right here, so, and let me just clear it a bit. Let's clear it a bit just to go over it to show you. Again, denominators are not the same. We find LCM. LCM is basically a number that both our numerators can go into without leaving a remainder. All right, or LCM can be used as any value. All right, and once 3 and 2 can go into it, any number that 3 and 2 can go into. The purpose of using our LCM, which is the lowest one, is basically help us to eliminate the factor of basically doing reducing at the end. All right, but again, if you use a value, so for example, I've used 12. If I've used 12, all right, let me show you that after using the 6. So 6. All right, how did I get 6? Is that I showed you my little way. I tried to see if the 2 can go into the 3 without leaving a remainder. No, it cannot. All right, because 2 goes into 3 one time and leave one remainder. All right, so after that, if I realize the lowest one can go into I just multiply both of them, and that would give me my LCM that I have down here. So that's going to give me that. All right, from that now, all I've done is that I know that my common denominator is 6. All right, what did I multiply the 3 by to get 6? I multiplied by 2 to get 6. So whatever I multiply the denominator by, I multiply the numerator by it also. 2 times 2, that's going to give us 4. So that was going to represent for our first fraction up at the top. All right, same thing over here. So 2, what did I multiply 2 by to get 3? To get 6, that's a 3. Or you could say 2 into 6 goes 3 times. So I multiply both the numerator and the denominator by 3. All right. So with that now, all I said is that 1 times 3 is going to give us 3. And that's going to leave us with a 7 over 6. Let me show you if you have not, or if you have used a value that is not the lowest. So let's say we know that 3 and 2 can go into 12. That's the next number after 6. 12. All right. So 3 into 12 goes 4 times. So that means I multiplied 3 times 4 to get 12. All right. So I'm going to multiply both the numerator and the denominator by 4. 2 times 4, that's 8. Plus 2 into 12 goes how much times? 6 times. So I've multiplied 2 times 6 to basically get 12. So I multiply the numerator by the 6 also. So 1 times 6 is going to give us 6. If we're going to have this, we're going to keep the denominator, and we're going to add the 8 and the 6, and that's going to give us 14. All right. So let's rewrite that 14 over 12. If I'm supposed to reduce this, all right, we know that a common number that can go into this is basically the simplest number because they are even numbers, 2. All right. So if I say 2 into 14, that's going to give me a 7. 2 into 12, that's going to give me a 6. So that my reduced fraction is now going to be what? as 7 over 6. And that's the same thing as what we had right here. It's the same thing. Same thing. Alright, so regardless, if I don't use the lowest common multiple, I'm still gonna end up with my same number. It's just that I need to reduce it. If you leave your answer as this, I'm gonna highlight, if you leave your answer as this, you're not wrong. But what you have done is that this is incomplete, so you would not get your full marks, because this is not in the lowest term. Alright, reducing your fraction to its lowest term, that's how you get your full marks. Alright, see there? We that. Alright, if I'm supposed to do subtraction, and I'm going to use the same values. I'm going to use the same values. I'm going to use the same 2 over 3. I'm going to minus half from it. Alright, LCM still the same. Why did I find LCM? Why am I finding LCM? I want to find a common denominator, because both the 3 and the 2, they're not the same. The denominator of both fractions are not the same. So what I've done is that I've basically found my LCM, which you already know which is 6. Cool. So with that now, we know that 3 into 6 goes 2 times. So we know that we're going to multiply both the numerator and the denominator by 2 in order to have the common, or find the equivalent fraction for it. Alright, and 2 times 2, that's going to give us 4. Alright, and then now 2 into 6 goes how much time? It goes 3 times. So now multiply 2 times 3 to get 6. So multiply the numerator by it also. So with that right here, so. And with that now, 1 times 3, that's just 3. And that's going to leave us with now 4 minus 3. We know the denominator is going to be 6, but 4 minus 3, that's going to be 1. This is my final answer when subtracting. So you realize it's still the same. It's still the same completely. Once the denominators of our fraction is the same, all we need to do with the numerator is just add it or subtract it if based on what the question requires. All right, if the denominators are not the same though, what we need to do is basically find our LCM. What's the purpose of finding our LCM? The purpose of finding our LCM is basically to find a equivalent fraction and make the denominators the same. Alright, to make the denominators the same, we need to find equivalent fractions. But instead of writing 2 separate fractions, we'll do it now with our LCM format. Alright, which is basically drawing our line. We have right here, so. Drawing our line that we have right here, so. Write our LCM right here, so. Alright, and then decide what number did we multiply both denominator by to get the 6 down here. So we know that we multiply 3 by 2 by 3 to get 6, so multiply the numerator also by the 2. All right, we know that we multiply 3 times 2 to get 6, so multiply the numerator also by that 3, and that would basically give us these two numbers that we have right here. So 2 times 2 give me this, 1 times 3 give me this. All right, all I need to do right there, so now is basically just keep the denominator the same and then add these two. Subtract these two to get the one that we have right there. Or this is what we're working with, subtraction. And that's how we basically add and subtract fractions. Alright. There are cases where you probably end up with something like this. Looking like let's say we have 1 over 4 minus, let me say plus, let me add first, plus 3. All right, many persons will see this and panic and wonder what to do. All right, every whole number can be represented as a fraction. How can we represent a whole number as a fraction? All we need to do, put it over 1. All right, if I'm put this now in a different color, let's put it over 1. All right, people think it's 7, so put it over 1. 3 over 1 is the same thing as 3. 10 over 1 is the same thing as 10. 5 over 1 is the same thing as 5. Anything over 1 is the same thing as the original number itself. All right, not anything under 1, or 1 over any number, Alright, this is not the same thing. 3 over 1 is not the same thing as 1 over 3. Two different fractions. Alright, this will always be 1 over 3. Alright, while this can be written as 3. Alright, please don't mix those up, please, I'm begging. Alright, so as I say, we can basically put it over 1 and we'll go ahead and find the LCM. Alright, once you're finding LCM for fractions that have 1 in one of its denominators, just know that the LCM is basically the other number. Okay, 1 can go into every number. Remember that. So 1 can go into 4, so 4 is the LCM. Alright, to get 4, we know that multiply by 1, multiply by 1. Alright, 4 times 1 is going to give us the 4. So 1 times 1 is going to give us 1 up here. So plus, now we have this. So what we basically need to do is now, what did we do to change a 1 to a 4? So 1 into 4 goes 4 times. Alright, anything you do to the denominator, you need to also do it to the numerator. Alright, so we'll just say now 3 times 4, that's 12. Alright, so we say 1 plus 12, denominator stays the same, 1 plus 12, that's 13. So our answer for this would be 13 over 4. Alright, and this would be our final answer for this. If we're subtracting, it's still the same thing, but I'm going to turn it around. So I'm going to say 3. I'm not going to put it over anything I said. 3 minus a quarter. Alright, 3 minus a quarter. Rule still the same. Once you have a whole number, just put it over 1 to make it a fraction, a complete fraction. Denominators are different. LCM right away. LCM, look, if the smallest number can go into the bigger number, yes it can, because 1 can go into every number. So that means our LCM would be the bigger number. Alright, and with that now, all we need to say now is 1 into 4. 1 into 4 goes how much time? 4 times. Because now multiply 1 times 4 if we get 4. Alright, so 3 times 4, that's going to give us a 12, minus 4 into 4 goes 1 time. So multiply this by 1, multiply this by 1. So 1 times 1, that's going to give us 1. So if we subtract now, we're going to say 12 minus 1. Denominator still remain the same. So 12 minus 1, that's 11. So this is now our answer, 11 over 4 when we subtract. Let's do a simple review of what we've been doing. Alright. So we're doing fractions, and if we have fractions with common denominator, so I say 5 over 7 plus 3 over 7. Alright, if I'm supposed to add this, denominators are the same, so let's write it back. And all I need to do is that we need to just add the numerators. 5 plus 3 and 5 plus 3, that's 8. Alright, this cannot be reduced, so this would have been my final answer. Alright, if I'm supposed to do subtraction now, if I have 8 over 15 minus let's say 4, a 4 over 15. Alright, the denominators again are the same, so I'll keep that. And then all I need to do is just subtract the numerators. Alright, let me not write it down this because I don't want you guys to think I'm finding LCM. Alright, denominators are the same, so I put 15. Alright, and all I need to do is just subtract the numerators. So 8 minus 4, and 8 minus 4 is how much? 8 minus 4, that's 4. So that would be 4 over 15 as our answer right there. So, alright, if we have something like this now, let's say we have a 3 over 4 plus a 1 over 2. Alright, if we have something like this, alright, we'd find the LCM. That's why I draw that line down here. So why do I know that? How did I know that I'm going to find LCM? Because the denominators are not the same. All right, once the denominators are not the same, what we need to do is that we need to ensure that we find our LCM. That's basically finding a common denominator for it. All right, how do I find a common denominator? Remember my two-step rule. Try to see if the lowest number can go into the bigger number. If it cannot, just multiply the both denominators and you can find the LCM. So in this case, my denominators are 4 and 2, and we know that 2 can go into 4. 2 can go into 4. All right, so that means my LCM would have been the bigger number. Okay, both numbers can go into 4. 4 can go into itself. 2 can also go into 4. All right, how did I get the 4 as the LCM? 4 into 4, 1 time. So let's multiply the numerator by the same number. All right, 3 times 1, that's going to give me 3. Plus 2 into 4 goes 2 times. So I multiply the numerator also by that 2. So let's remember, whatever I multiply the denominator by to get my LCM, I need to multiply the numerators by it also. All right, so we say 2 times 2, that's 4. So 1 times 2 would give us 2 right here. So if I'm going to add this, I'm going to end up with a 5 over 4 as my final answer, and this cannot be broken down. All right, and again now, let's say I have a 2 over 3 minus a 7 over 12. All right, with this, realize clearly the denominators are different. Realize that clearly, denominators are different. If the denominators are different, all we need to do is that we find LCM. All right, two-step rule. Try to see if the lowest number can go into the largest number. If it cannot, just multiply both of them together. Good thing about this, the smallest number can go into the largest number. So we say 3 can go into 12, because we know that going into it 4 times. If you don't know that, use a calculator and test. 12 divided by 3. See if you get a whole number. If I get a decimal, that means it cannot go into it. All right. So LCM would have been 12. So it's a 3 into 12 goes 4 times. All right. So multiply the numerator also by the 4. So 2 times 4, that's 8. Minus 12 into 12 goes 1 time. Multiply this also by 1. 7 times 1, that's going to give me a 7. So what is basically telling me now that my denominator is going to be the same, but if I'm supposed to subtract 7 from 8, I'm going to left with 1. So this is saying now, if I have 2 over 3 and I minus 7 over 12 from it, I'm going to end up with a 1 over 12. And that is basically us adding and subtracting fractions with like denominators and unlike denominators. Alright, so let's look at having mixed numbers now. So let's say you have 2 and 1 over 2. And they said I should subtract 4 over 5 from it. Alright, so if you realize clearly, let me just rewrite this. If you realize clearly, basically I have a mixed number and I have a proper fraction. Alright, so what I basically need to do with working with these is basically change our mixed number. Any mixed number that you see, change it to an improper fraction. Alright, so I'm seeing clearly I have a mixed number right here, so I can change this to improper fraction. And if you watch the previous video, we already know how to change it to improper fraction. Just multiply the whole number with the denominator, then add. So I'm going to change it to multiply that and then add the numerator up there. So alright, so if I multiply 2 times 2, that's going to give me 4, and then 4 plus 1, that's going to give me a 5. The denominator should remain the same, minus 4 over 5. That's where we've now changed the 2.5 to 5 over 2. Alright, so now I can do my normal thing that I've just learned. Alright, we're subtracting, and once we know that we're adding or subtracting fractions, if the denominators are not the same, we find LCM. Alright, so LCM for this would have been 10. Alright, so with that, 10. So we say 2 into 10 goes how much time? It goes 5 times. Alright, so multiply operator by also 5. So we're going to have a 25 minus, so it's a 5 into 10 goes how much time? 2 times. So multiply operator by 2. 4 times 2, that's 8. All right, so we know that this is gonna still be the same thing down here, so we'll end up with a 17 up at the top, because 25 minus 8, that's gonna leave us with 17. All right, if people are wondering, how did I get 10 as the LCM? Remember, looking at denominators are unlike, we do our two-step, we can call it two-step trial, basically to figure out if the lowest number can go into the bigger one, and then if it cannot, must multiply them together. So 2 can go into 5, yes, but it's leave the remainder of 1. So 2 go into 5 2 times, but leave a remainder of 1. However, that cannot work. Why? Because you cannot go into it evenly. Alright, so what I do next is just multiply both of them together. That's how I got my 10 down here. So then I say 2 into 10, and that goes 5 times. So multiply up here so by 5 also. 5 times 5, that's what gave us the 25 right here. So there was a 5 into 10 goes how much time? 2 times. So multiply this by 2. Anything added to the denominator, do to the numerator. Alright, so multiply by 2 also. And then 4 times 2, that's going to give us 8. Do our normal thing, carry back our denominator, subtract our numerator. And that's how I got my 10 right there. So. Alright. Same thing, if I had this. If I had that, all I needed to do is that do the same thing again. Change our improper, our mixed number. Alright. 1 times 2, that's 2 and 1, that's 3. So I'm going to end up with a 3 over 2. Minus, let's keep this the same. Alright, because that's already a fraction. Alright. Find our LCM. LCM again is same 2 and 5, so now LCM is going to be a 10. Alright, 2 into 10. 2 into 10, let me use different color. Just to not confuse anybody. 2 into 10. 5 times. Multiply this by 5. 5 into 10. 2 times. Multiply this by 2. Alright. So then we say 3 times 5. That's 15. Minus 2 times 2. That's 4. Denominator remain the same. I mean, if we don't have subtract now. 15 minus 4. That's going to give me an 11. Alright, that's going to give me 11. Can do one more. Alright, this time I'm going to do one with addition. If I have 2 and 2 over 3 plus 1 plus 1 and 1/5. Alright, if you realize you have two mixed numbers right here, so rules remain the same. Change them to improper fraction. 2 times 3, that's 6, and 2, that's 8. So it's 8 over 3 plus 1 times 5, that's 5, and 1, that's 6. So it's 6 over 5. Alright. Denominators are different. LCM. Cool. 3 cannot go into 5 without leaving a remainder. So no, that's not going to work. So let's multiply 3 times the 5. 3 times 5, that's 15. Alright. 3 into 15 goes 5 times. So multiply this by 5, multiply this by 5. In that case, we know that 8 times 5, that's how much? 40. Plus 5 into 15 goes 3 times. So multiply this by 3. 6 times 3, that's 18. Denominator remain the same. 40 plus 18, that's 58. That's 58. Alright. Can this be broken down? No, 3 can't go into it. No. So this would have been our answer. That we have right here. So. Alright, so that's just basically working through addition and subtraction of fractions. We can do one more. Let's say I have 1 and 1 over 7 plus 3 over 4. Alright, so it's a 1 times 7 plus 1, that's 8 over 7 plus the 3 over 4 remains. Alright, can 4 go into 7 without leaving a remainder? No, it cannot. Alright, however, we know that once it cannot, let's multiply both of them together. 7 times 4, just use a calculator if you don't know, but that's 28. Alright, 7 into 28 goes 4 times. So multiply operator by 4. 8 times 4, that's going to give us 32. Alright, plus 4 into 28 goes 7 times. So multiply both numerator and denominator by 7. Alright, 3 times 7, that's 21. 28 remains the same thing down here, so 28 remains the same thing. Let's add the numerator. 32 plus 21, that's 53. And this would have been our answer. 53 over 28.